I'm recording this talk again that I gave in May, both at UBC and at the Pacific Northwest PLSE workshop. All right. So my student Mo recently graduated, and in his master's seminar, he put on the slide, deep learning is one of the best ways to do program analysis. And, he kind of knows how things are going. So, of course, being a canny guy, he read out, deep learning is one of the ways to do program analysis. Let's think about this statement and how true it is, maybe not deep learning, but machine learning in general and program analysis. And that's going to be what I'm going to talk about today. So let's start by thinking about some of the things that machine learning is good at and some of the things that might be bad at. And so you think about it and you're like, okay, what can machine learning do? It can do classification, it can do inference, and the thing that has been super talked about recently is generative AI. And let's also talk about analysis and deduction. So I'm going to go through each of these things and I'm going to talk about machine learning and about program analysis approaches to them. I'm going to talk about so I'm going to talk about some of the work I've done in these areas and also bring in some work that other people have done as well. All right, let's start by talking about classification. Machine learning is great for classification. And so it's great. And so what we did in 2008, a while ago now, was we were analyzing. So what we had this thing called trace matches. And the point was to generalize state machines so that they could consider actions of multiple objects at once. So you have, for instance, an iterator and a list, and you want to say, well, you can only call next on the iterator if you've called has next on the, you have the iterator and the list, and you can only call a method on the list after you call a method on the list, you can't call a method on the iterator. So when you remove a method from the list, you cannot call anything on the iterator anymore. Anyway, trace matches, and what we wanted to do was we were doing a static analysis to figure out which trace matches did not need to be evaluated at runtime. And so you can promise that you have this property, and statically you can say this property always holds on this execution. Of course, you can't always do that, and you get a bunch of false positives. So one thing you can do is you can put runtime monitoring, and that's kind of okay, but you still might have the failure and you just recover from it. It's better to not have to worry about the failure at all. And so another way we tried to do was we tried to just reduce monitoring overhead by detecting false positives. And so we identified a number of features in the code depending on what we saw on the analysis. So for instance, if our analysis timed out, then that's a feature. If there's something that we called a delegation call, then that was a feature. And so we collected these features and we ran it through a machine learning toolkit with some training and data and some test data. And we identified many false positives. And so after our machine learning phase ran, then you get a smaller set of potential false positives, which you can then monitor. And then the true positives, you know that these are things that you care about. The false positives, you monitor them, and the things that are definitely not, then you don't have to care about them. So a random comment is Weka is machine learning toolkit framework, and I kind of knew about it, and it's actually, when I came to New Zealand, I went to Kapiti Island, and Kapiti Island has Wekas, and so you put your lunch on a picnic table, and maybe you look away for a bit, and then the Weka goes and grabs your lunch and tries to run away with it. Fortunately, your lunch is kind of heavy, so you can run after the Weka and get your lunch back. But the Weka toolkit was first from the University of Otago, I believe, in New Zealand, and they named it after this bird, which will steal your lunch. Maybe in the same way as machine learning will also steal our lunches, or not, is kind of what I'm saying in this talk. Classification is broadly applicable, and another example of classification in my past work is from this MSR14 talk by Quinhan et al., and it's finding patterns in static analysis alerts. And so again, it's an idea of identifying false positives so that you tell the programmer, these are the things that we think are really going to be true positives, and they can look at the true positive, the thing that we think is a true positive, and decide if they should actually worry about it. In this case, it was using find bugs. These days, I always use spot bugs. But you rank the importance of the 100 alerts you get from find bugs. And you're like, well, look, they all might be an issue, but look at these 5 alerts first and try to figure out what's going on with them. So again, same idea, extract a feature vector and run it through a machine learning toolkit. All right, classification via deep learning. And so I guess Mo's slide was about deep learning. Okay, fine. This paper from ICSE 23 is a review paper of a bunch of different deep learning approaches. And so they basically looked at different papers which tried to answer the question, does this code have vulnerability or not? And so it's a meta-analysis, I guess. Maybe it's not a formal meta-analysis, but they do identify many different papers. And so they study the behavior of 9 deep learning models on 2 data sets. And the claim that they say is that deep learning outperforms static analysis on this task. So I'm willing to believe that could be the case. It can be good for some things. All right. The next thing that I want to talk about is regression. So we've talked about classification, and classification is labels. And so instead of using labels, regression is, and I'm not a machine learning person, so please forgive me if I don't get this quite right. But instead of having discrete labels, you produce an answer in a set, in a range. And for me, it's like, okay, regression has a lot of applications, but programming languages and software engineering are not a great application for regression. The issue is that, okay, now you have this number, and I guess, especially in programming languages, we're really not that great at dealing with numbers. And so I think it's not as applicable. Could imagine some software engineering applications where you have a number, and okay, you can do that. Okay, the next thing I want to talk about is inference. Okay, so we've done some work on inference, and we submitted this to ICSE 24 and didn't get in, so we'll try again. But we thought that this was good work, and maybe you can read about it one of these days. So what we did in this case was code representations for improved program analysis. And so there have been a bunch of works in similar domains. In this case, what we did was for WebAssembly, and we had some applications. The applications are not the focus of this work, but they do show that our technique works on certain problems that other people have worked on in the past. And so the 2 applications that we talk about are method name prediction. So basically we compute a representation of a method, and we use our training data to say, look, this method, it looks a lot like other bubble sort methods. And so you can classify what a method is based on the representation you have. The other thing you can do is you can do a inference of return types. And so WebAssembly is our target, and WebAssembly has really coarse types. And so basically it says, look, it's, I believe, a 64-bit floating point blob. And so we can infer more detailed things like this is actually not just a blob, it's actually a pointer to an int. Okay, so I don't want to go into this in great detail, but basically we have a WebAssembly program, and then we have the AST, and we compute a representation or 2 representations of the AST. One is a code embedding, and one is a path sequence. And there's technical differences between them, but they're actually equivalent. And so the code embedding is this long vector, and it tells you some sort of summary of the method, which our results find to be useful. And the other is a path sequence. So instead of having this long vector, we have just like in element 1, we have 5, in element 5, we have 2, and so on. So you have this path vector, and it gives these two representations. And we use these two representations to do machine learning on these with the applications I told you. A different application, which is similar to ours, but it came way before, is JS Nice, and I find this to be really good work. So you had obfuscated JavaScript code because it's smaller and you don't want to give out your source code, or you just have huge amounts of source code and you don't want to put it on a web page. And so now you have these web pages and they have blobs of JavaScript on them. Can you recover the structure of these codes? And yeah, you can use machine learning techniques to say, look, this is this structure that's a for loop, and hey, that's a for loop, so the parameter, the variable should actually be I, and so on. So it infers likely identifier names using machine learning, using a big corpus. Cool work. Okay, so those are the traditional things that if you talk to a machine learning person, they'll say, yeah, that's inference. I want to talk about some other things which we typically don't consider to be machine learning techniques: test generation, program repair, and program synthesis. And so let's talk about them by talking about examples. So a few years ago, I worked on this test generation code, and not test generation for figuring out whether your program's correct, test generation, in fact, for figuring out whether your hardware meets the specification. And so in this case, what we did was we had a model of the hardware. In this case, it's remote DMA, so it's like you have different network cards, and they can put content in the memory of another computer on the network. So it's a fast way of communicating between machines on the network. So we had a hardware model for that in Alloy, and what we wanted to know was whether the behavior of the system conformed to the Alloy specification or not. And the Alloy specification came from the text specification that they wrote about their system. And we then generated litmus tests from the specification, and we ran the code on the actual machines, and we found a couple of cases where the specification diverged from the behavior. So that was an OOPS paper back in 2016, I believe. All right. Another thing which is inference, but which we don't consider usually to be machine learning inference, is program synthesis. And so the quote is that program synthesis is a class of techniques that are able to generate a program from a collection of artifacts that establish semantic and syntactic requirements for the generated code. So basically you have this constraint system, and you want to do a search on this in a space for a program that meets your needs, right? So that's a kind of inference. It's search-based inference, and so the things I'm talking about are basically search as opposed to some sort of statistical thing, right? All right, so moving on. Now I'm going to talk about the thing that everyone cares about now: generative AI, right? And so is it a generalization of inference? Well, sort of, but it uses different techniques. It uses statistical techniques, and you don't certainly get a exhaustiveness guarantee as you do with a search-based technique. And so, of course, the famous things these days are Copilot and ChatGPT. So what I want to talk about now is the question, is generated code any good? And so I'm going to talk about two ways you can do this. The first way you can validate the quality of code that you generate is by using test cases. And so Nguyen and Nadi did this, and the corpus they chose of problems was LeetCode problems, which is great. This is pretty clever because you have this large corpus of problems, and each problem has a test suite, which is pretty good at telling you whether the code is correct or not, right? So they did this, and 57% of the Java programs they got passed the test cases, which is pretty good. It's probably better than the average junior developer. And then JavaScript, 27% passed, which is not quite as good. So then I was teaching this course last summer, And so the best course project was this paper where it's like, let's use Copilot to generate code, and then this is a course on with some formal verification content. So let's use Daphne to verify the code that's generated. So this gives you a different set of results that you can interpret about the thing, right? So okay, you generate code, and then you try to test it you try to verify it formally using Daphne. So there's these things that can happen. Either you verify that it's correct, assuming that your specifications are right, then it's great. You know that it actually generated code that is actually correct, as opposed to just being, well, it's probably correct because the test suite is pretty good. No, this is actually correct, assuming specifications are correct. That's great. The other thing that can and does happen is like, can't verify it. That's much less satisfying because maybe it's wrong. So maybe you use this in conjunction with like leak code test cases. So either the code is wrong, and then you can try as hard as you want, but you're not actually going to be able to verify it. That's what verification means. Or you're just not smart enough to verify it. Or I'm not smart enough to verify it, and whatever, right? So it's much less satisfying in that sense because you don't get this guarantee that the code is incorrect. Anyway, we in that work, we found that 4 of the 6 problems that we generated code for, most of them being pretty simple, we managed to verify. I had a summer student work on this problem as well, and they got a bunch more. And basically, I think the thing that I think is if the problem is pretty simple, then you can generate code for it and that'll be fine. If the problem is more complicated, then maybe the code is wrong, maybe the code is right, I don't know, but it's certainly hard to verify. Maybe that's not saying something very surprising, but it's good to keep in mind. And so it is, of course, possible to use especially ChatGPT interactively, right? ChatGPT. And so you can say, okay, please generate program to do blah, and it generates program to do blah, and you're like, no, that's not wrong because it got this case wrong. And then you can do that over and over again and get revised programs. And using this in conjunction with program verification, you can then get guarantees about whether your code is correct yet or not, right? So that's an interesting approach, which gives you some confidence about what you get. All this is, of course, assuming that you have good specifications, which is actually hard. And so the ChatGPT hype, I think, ignores or obscures the issue that, look, it's hard to generate specifications as well. Okay, now I want to talk about a case where machine learning is definitely bad. I think it's bad. Deductive reasoning. I think it just sucks at this, right? And there's examples where you give like ChatGPT math problems and it's like, what? Okay, so back in the day, AI included like search, as I've said before, and so deductive reasoning in particular, there is ACL2 and it generated these proofs that were readable. So again, there's this old school AI notion, which was search, but the newer school AI notion is statistics, right? And I think statistical approaches are great for some things. They certainly do very well at generating plausible sounding text. But if you want the actual answer, I have no idea how you do that using statistical techniques like pointer analysis using statistical approaches. No, I don't think that you can actually get an answer that is actually right. You can get an answer that's like, that seems reasonable. We look at this code and we think that's right, but you don't know for a fact that it's right. And let's look at this in a bit more detail. So you have 2 pointers. This is C now, star P and star Q. And so the question is, do they possibly alias? And so in particular, the question you might ask is, you have this code which says star P equals 5, star Q equals 2, and what is star P going to contain? And so it could be this way or it could be this way, right? So it could be P and Q point to the same thing with some code I haven't showed you, and you do that, and then afterwards, star P contains 2 because it contains what star Q contains. The other possibility is that they point to different things, and then star P contains 5 and star Q contains 2, right? So these are the 2 possibilities. You can use stats to guess what it is, but you don't really know. You could say, well, look, I think they're probably going to be not aliased, which is going to be true most of the time, but it's not really the actual answer. the actual answer is complicated, and you use, for instance, there's a bunch of different algorithms for this. One of the algorithms is CFL reachability, and so you construct this graph and you do a graph traversal on it to answer your question. So maybe one way to say this in brief is, do you want reasoning or do you want reckons? And I think that statistical approaches give you reckons, which is fine for some things, but I don't think it's fine for pointer analysis. All right, the next part of this talk contains hot takes. And so I promised hot takes. Here are some hot takes. So what does ChatGPT think about this? I've put these hot takes on the web as well, so you can consult them. I asked Lucas to engineer me some prompts because I've actually never used ChatGPT and just read about it on the internet. And so the prompt is, give me 10 hot takes on how machine learning will affect programming languages, software engineering in the next 10 years. All right, hot takes. Developers will need to have a strong understanding of statistics and data analysis in order to effectively incorporate machine learning into their analysis. Well, that's kind of tautology, right? It's like, well, if you want to use stats, you need to know stats. I mean, maybe you can try to use it as a library, is the counter argument to this, but no, you should probably know something about stats if you're going to effectively use about this and not just be kind of using things you don't know what you're using. Natural language processing and speech recognition will become more prevalent, leading to the development of new programming languages and tools to support these technologies. I don't really believe that one. I think that it's just another input modality. You get a stream of text, maybe you get a tree, and you just need to understand that stream of text. I don't think you need to change your programming languages to support this. Programming languages are powerful. As machine learning becomes more widespread, developers will need to prioritize the ethical implications of their work, such as data privacy, bias, and accountability. I agree with that. I don't think it's really restricted to machine learning. As soon as we have computers that are kind of powerful, this is the thing that you care about, right? So if you have all the data in the computer and you have database lookups, you already need to think about accountability and data privacy. Bias is also a thing. I guess maybe it's more of a thing for machine learning. So this is a hot take. I kind of agree with this. I'm not going to give you all the 10 hot takes. I'm going to give you 4 that I chose. And then hotter and hottest takes. Developers will increasingly rely on machine learning to automate software testing and debugging, reducing the time and effort required to find and fix bugs. Do we believe in better tools? And maybe it's a bit heretical for someone who does research in software engineering, but it's like tools are getting better. I think the track record for selling tools has been difficult, and people will use some tools when they're in the IDE. I guess the thing about machine learning based tools is that they might be cheaper, but I don't think they're really cheaper than the static analysis tools we already have, right? It's actually more expensive to run it per unit cost. Like you run Coverity and it's actually relatively cheap to run. You run ChatGPT and it actually costs a significant amount of compute to run. So I guess the first question is, do you believe that tools are going to be helpful? Sure, maybe. Machine learning based tools, I don't particularly see a reason why machine learning based tools would necessarily be helpful. Of course, for testing and debugging, I want to talk a bit about when it can be useful for writing the code. I guess another question is about finding the problem, and maybe there could be a tool which is statistical, which says, well, the code error is probably here. Could be. I don't know. All right, so those were the hot takes, but of course, ChatGPT, you could chat with it, and you're like, give me more hot takes that are more hot. Machine learning will eventually make traditional programming languages obsolete as machines become better at creating software than humans. I mean, it might make junior developers obsolete. I don't think it'll make people who really know about stuff obsolete. The problem is, how do you get from a junior developer to becoming someone who actually really knows about stuff? And so that's a problem, I think, everywhere, but it's certainly a problem here. And then, as I said before, I think the problem of specifying things is still hard. As machine learning becomes more advanced, developers will need to focus on building systems that are transparent and explainable in order to ensure that they are trusted by users. I think we're already pretty bad at doing this. I mean, like, do you actually trust Facebook? I sure don't trust Facebook. I think it's a thing that's important, but the incentive structure we have set up in society may not be aligned with that. There's an interesting thing, which is that it's kind of formulaic, right? And so you can see that by flipping between these. It's like, oh, it uses the same stem, but the words are different. Anyway, so as I'll say later, I think it's not really good at creativity. It can maybe point you at some places you didn't look at, but it's not going to generate completely new things for you. Anyway, more hot takes. Machine learning will eventually lead to the development of conscious machines, creating a new era in which machines and humans coexist as equals. Really? I mean, maybe you should stick to science fiction. We don't really even know what consciousness is, right? And so I think, well, I asked for hot takes, and I don't really buy that hot take. As machine learning becomes more prevalent, it will lead to the creation of new types of software applications that are designed to manipulate and exploit human emotions. And I mean, that's what marketing is, right? Are we going to get automatic marketing? Maybe. I guess the scale of marketing could become even more of a danger. I guess I'm like, well, things that computers do you could have done before, but it was harder. And so maybe it does change things that you can do this more easily. Could be a concern. Maybe we need regulation in this area. All right, and the final set of hottest takes. Can you make the takes even more controversial? The rise of machine learning will lead to the creation of new types of software applications that are designed to replace human workers, leading to widespread job displacement and social unrest. I mean, 4-hour work week, right? Like, we've talked about not needing to work for a while, and maybe we don't need to work now, but we need some sort of purpose in life. I don't know. Anyway, I don't think technology is a problem here. I think society is the issue here about needing people to work and what people should do. The development of advanced machine learning algorithms will eventually lead to the creation of true artificial intelligence capable of independent thought and decision making. Sure as hell hope not. Should you trust machines? I don't really trust machines. How do we know that trustworthy? We don't. The increasing use of machine learning in software development will lead to a new era of digital imperialism, with the most advanced machine learning algorithms being used to dominate and control global markets. I guess, once again, it's like, were you really able to fight US hegemony in the 60s? Well, at limited scale you could, but not on a global scale, right? So what does digital imperialism mean? I don't know. Eventually, the rise of machine learning will lead to a new era of technological singularity, in which machines become more intelligent than humans and take over the world. I mean, that's kind of science fiction. There's a lot of movies and books about this possibility, and I guess if you want to think about it, go watch some of our creative content, which was created by people and not machines. So that was ChatGPT's hot takes. What are my hot takes? Okay, so I sat down and thought about it, and it's like, okay, maybe they're not that hot, but they're what I think. Machine learning is a super useful tool when it's applicable, and so it really does allow you to do some things maybe that you couldn't do before or that were hard, right? So this is true. It can consider more input than we can consider in certain cases. Although we're good at making some decisions on gut feelings that are surprisingly good sometimes, not all the time. Machine learning won't make our fields obsolete. I think more research is still needed. I think part of the trick is using domain knowledge to drive machine learning. You got to know stuff. Once you know stuff, this is a tool, and you can use this tool to do more powerful things than you could do before. Here's a report from Computational Linguistics, which maybe is 15 years ahead of us in terms of ML techniques being there. And so you might say, well, look, isn't Google Translate all statistical? So I asked a friend of mine who is a computational linguist. And so he's like, here's a bunch of papers. So I looked at the papers and talked to him about it. And so the question that this paper is looking at is understand why sometimes random word embeddings work as well as pre-trained embeddings. And so how do you answer that question? Well, you need to understand stuff, right? So you need experimental efforts in linguistic representations, and you have to be able to manipulate the model architecture. So you have to know this is what a model architecture is, and I can change it by changing where the layers go and whatever. I'm not obviously a computational linguist, but you need to have this domain knowledge to be able to use and understand this this technology meaningfully. All right, so I have hot takes, and let's have some hot takes that are specifically about generative AI. And so here's my hot takes. Generated code can be good actually, so it's a tool, and in some cases it's actually legitimate to use it, but I wouldn't trust this code further than I can throw it. This is Spot the dog. Spot the dog loves to fetch snowballs, I guess anything else you do, and so I'm not that good at throwing balls very far. I can throw people, I can't throw balls. Anyway, you have some code, you generate it, and if you can test that code to your satisfaction, you look at the code. If it's simple, if it's just calling APIs, and you see the APIs have names that you think it does what you want, then that code is probably as good as code you would have written to put up a window, for instance. That's fine. Code that's more sophisticated, wouldn't necessarily trust it. Code that I can't understand, code that I can't test, not so good. And so like, I guess first year programming, like you have people who don't necessarily understand how to write programs. Maybe there's a good assignment about understanding the code generated and talking about it. Maybe people should talk more about code and like focus less on writing code. I guess I could see that. But in terms of actually generating a code, I'd use it, but with reservations. So it certainly is good. You got a blank page, and blank pages are terrible. You have this blank page, you don't know what to write. It's like, sucks, right? And so generative AI does give you stuff to work with, and it is easier to start with something broken that you know is broken and fix it. If something's broken and you don't know it's broken, then you have a different problem. But you know you have nothing and you want something. Generative AI is good at that. Then you should do work and make sure the thing is what you want. You don't have to reinvent the wheel, right? Wheels are great. People have invented wheels already. You can use wheels to drive power, but you can also use wheels to... Anyway, wheels are great. Don't reinvent them. I think, as I've said 2 times before, they're not super good at giving you something really new. They're giving you things that people have said already, but it's kind of woo-woo, but there's just that spark of creativity, and I don't think it's super good at doing that. It just rehashes things. And of course, people say a lot of rehash things too, but I think the potential to come up with actually new things is better for people than it is for generative AI. All right, so some other things that generative AI is bad at. So I'll talk about these things. Identifying the problem. There is the problem hallucinations, or the question of whether objective truth exists, respecting IP, and ensuring security. And so choosing a tool is sort of the easy part, but you have to know what the problem is before you choose the tool, right? And so you have to have a plan for doing these things, and you have to have a vision, and you have to have a specification. And I think generative AI requires you to have a prompt, and so you need to know what prompts to give. An example of objective truth is, what is the highest waterfall in New Zealand? And there's an answer. Sutherland Falls is the highest waterfall in New Zealand. Generative AI doesn't really know this. Google can have problems with this. There was just this week, someone noticed that Google gave a totally non-consensus answer about the universe age based on some things that people said that appeared in the news, but that's not the consensus, right? And so I think some things are true, and I think generative AI is not good at knowing things that are true. And it, of course, also makes up citations, which is another thing that is not great. It will steal stuff, right? And so Kias are great. Kias will also steal stuff. I keep on talking about birds that steal stuff. So your Kias are going to steal your stuff. They're pretty smart. People say they're as smart as 5-year-olds. So Kia steal stuff. Generative AI also steals stuff, and I have mixed feelings about IP in general. But you probably shouldn't go and steal stuff in the way that generative AI does. And ensuring security is also a challenge, right? So it generates code, and the code can be wrong. One of the ways the code can be wrong is by being a copy of insecure code that someone else put on the internet. Of course, if you just program by Stack Overflow, you have this problem too. So part of it is knowing, at least with Stack Overflow, you should be evaluating the source of your code. If it's ChatGPT, it's kind of laundered, and you get this code, but you don't know what the code is, the provenance of the code. But in terms of being not all bad, we have hackathons, and how does ChatGPT generated code compare with hackathon generated code, right? By people who are sleep deprived and writing throwaway code. And it's like, yeah, maybe these are equally bad code in that sense, but they are prototypes. So maybe that's fine if you think about it as a prototype. But then, of course, the problem with prototypes is that sometimes they get deployed in production. All right, so just wrapping up now. We've talked about applications of machine learning, classification, inference, generative AI. And we've had some hot takes, both hot takes that ChatGPT generated and some hot takes that I generated. And I think, to say what I think, it's a useful tool, but it also won't make us all obsolete. Thanks.